importance of introducing new data types to the database in order to support graphical applications where you would need to be able to draw a frame of your image in at least a second or two, which of course is pretty slow by modern web standards, certainly very slow by modern graphics standards. But there's two sort of main cases for data types. You can use them both to improve performance by increasing locality, and we'll get into some of the mechanisms, so that will be clearer why that works. But it also just really helps you reason about how your queries work and how your data is structured, and gives you a lot of really powerful tools for working with your data. And we're going to look at all of that. I will note that premature optimization is the root of all evil, and there are times when I might recommend something which is not necessarily always the ideal performance solution in every case. However, I'm trying to give you good defaults to go to. You may have cases where you sort of think to yourself, oh, but maybe in this corner case, you should do something different. Yes, that is the case. However, what I want to encourage with all of this stuff is that you kind of come out of here with sensible defaults, and some of these may be breaking habits that you've picked up or picking up some new habits for Postgres. So let's begin with the basics, because that's what we're here for. Here are your basic types. You've got your surrogate keys, you've got text, you've got numbers and dates and times. The vast majority of all the data you have in any database is these things. For keys, you should always include a surrogate key. Don't use your natural keys as the only key. That said, of course, if you want to have uniqueness constraints on a natural key, that's very sensible. But my advice to you is that natural keys in living software systems do evolve over time, no matter how confident you are that you understand zip codes or names. Inevitably, you're going to wind up with something changing, new character encodings 5-10 years down the line. My advice is when you're designing your tables, always include some kind of a surrogate key and model your natural key with constraints. What should you use for your key? Use big serial or UUID. Now, for a bunch of complicated reasons, this is not the default. And for even more complicated reasons, the difference between big serial and serial, which are sort of special cases of column IDs that basically do something like auto-increment in MySQL, you end up basically spending the same amount of disk space anyways because of CPU architecture and how pages get packed in a lot of cases. This is all kind of like inside baseball stuff, and we'll talk a little bit more about it later. But when you're creating a table, I want your reflex to be use big serial for your ID, right? If your table is small and will never grow to be really big, don't sweat the extra 4 bytes. It doesn't matter at all. If your table is big and it's going to get bigger, having had to replace keys on live operational tables in a panic, as anyone who's run a really big database here will know, it's going to happen, you're going to do it, it's going to catch you at a time when it's inconvenient. There's never a good time to fix this. Just use big serial for now, and then you won't regret it later. It's a good default. There's almost no circumstance where the difference in extra storage cost, which as I mentioned is not always the case, is worth worrying about should you use serial versus big serial. Make your habit big serial. The other kind of key that's really nice to use is a UUID. UUIDs have some trade-offs as well in terms of storage size. But UUIDs are great because if you generate random UUIDs, you can do that at the edges of your system. The key space is big enough, I think, to address every proton in the universe. Is that? Maybe it's just every star in the universe. But it's a really, really big key space. And what you can do if you're using random UUIDs is actually make sure that out in the edges of your distributed system, you can generate those in JavaScript or in application code, and you don't have to worry about locking some central table. As your database grows, if you want a shard, or just if you're trying to avoid kind of heating up the system, if you're using UUIDs for very large tables, it has nice properties. There are some subtleties in trade-offs around kind of index organization here, which are worth thinking about if you're really getting into this stuff, but I don't know quite what happened there. Okay. But in general, either of these are really good defaults. Both of these will work pretty well for you. And you have to create the UUID-OSSP extension to get access to the UUID generation functions. There are also UUID generation functions in the PG Crypto extension if you already have it. These are, for every distribution I know of, available by default. You don't have to download or compile anything extra. Text, Simon's already covered this. How many people have a MySQL or Oracle or SQLite in their background here? A bunch of you. Varchars and all these kinds of things, just use text. Try not to use varchar or char. They're actually more expensive because they do similar things to text under the hood, but add additional checks. Unless there's like some really important reason that you really want to constrain the length of your text to, 100 characters for, I don't know, legal reasons or something like that, just use text. Text should be your default when you're creating things. It's a sensible default. Text display, no, PSQL will use the widest value for display. So I mentioned this in the previous talk, but if you type \x space auto in PSQL, it will automatically switch between vertical records or horizontal records, depending on how wide your data is. And if you put that into your .psqlrc in your home directory, then that will always be set at PSQL startup. There are some other nice things you can do in there, like put in different prompts and so on. It's worth setting up. I want to talk a little bit more about text and good habits for using text. When you're working with text, if you have an index and you do a query, a like query that has a suffix, right? The index will support that. A B-tree index will support that. If you have an invert index, then you can do suffix matching. Now, this is really useful for people who have email addresses in their database, aka people who build web applications. If you don't do this, right, so what we're doing here is we're creating an index on the reverse of user emails, right? If you query this query without this trick, you'll always have to do a full table scan because it has to check every record to see if it matches because it can't use the index. So you create a functional index on the reverse, and then you query on the reverse of the email against the functional index of the reverse. And yes, this is a little bit silly, but we'll come back to that too, but this will perform quite nicely. Question? So, yeah, I mean, if you are creating an index on very, very large text values, that can be expensive. But if you have emails or URLs or things like that, index cost is always a trade-off between sort of additional write bandwidth, obviously, and lookup performance. So it kind of depends on what you're storing. I wouldn't index, whole novels, but email addresses and URLs, it's usually worth it, depending on your read load. No, so specifically, they're the same under the hood. We're going to come back to it. Simon talked a little bit about toast and a little bit about in-record and out-of-record storage. If you're using like varchar, it's actually, if you say type varchar 255, then it's still going to be a text under the hood, essentially, but it's putting an extra check at write time to make sure that it's not exceeding your expectations. Depending on your application, like I said, that might be beneficial. If you have an old C application where you're sort of, copying something into a fixed length string buffer, then knowing that you should still check, but reducing the likelihood of problems there might be worth it. But for most people in most circumstances, I recommend text. You can create TS vectors, full text search vectors, and then index with gin to look up individual pieces of strings more efficiently. So here we're tokenizing strings and creating a TS vector, a text search vector. And then this actually supports some limited amount of regular expression searches indexed if you install the PG trigram extension. And this is relatively new stuff from the Mad Russians. Again, we can't go into too much depth on any of this. We've got a lot of ground to cover, but I'm trying to give you pointers. So, a quick question? Yeah. So let's talk about times and dates. Timestamp TZ, not timestamp. Timestamp TZ. paying the same storage anyway. You will regret it less often. You never want a timestamp. You always want a timestamp TZ. Why is it not the default? The SQL standard. The SQL standard is a 35-year-old tire fire that we all have to cope with. Just make your default to always finish with a TZ at the end of fields. Of course, you see sometimes people getting confused. Usually figure it out before you hit production, but you don't want time. Time is time of day. So that's time without date. Sometimes you do just need a date. Originally I just said no one ever uses time, but someone said sometimes you actually do want time of day for cron jobs and things like that. Okay. But usually what you want is timestamp TZ. When you're working with dates and times, Postgres has the best support for dates and times of any programming environment anywhere I've ever worked with, and that is a fairly significant statement. Postgres has support for that missing week when the Pope changed the calendar in whatever year that was. If you look in the manual, it will tell you this. There's lots of good tricks you can do, and I'm just going to scratch the surface here. Selecting date trunk to the week of now will always give you a timestamp from the beginning of the week. This is useful for grouping queries and so on. So here's an example of a query where we're grouping users by day and doing a roll-up on that. If you're doing time travel, you can subtract an interval from, so you can just say, I want now minus a year. If you want the beginning of last year, you could then date trunk this to the year, and no matter when you run that query, right, this will always work, right? Next month it will be right. The month after it will be right. So when you use these kind of now minus interval, it's really useful for people who are answering sort of analytic operational business questions. Very helpful. Here's generate series with this trick. This is all of the days last month as a set of rows. So we're generate series from month now minus a month to month now in 1 day intervals. Boolean values. Sometimes people will use bit by mistake. Bit is a bit string. You don't want bit strings. You just use Booleans. Don't worry about packing a bunch of bits into a bit string value. You're just making more work for the next poor person who has to maintain your code. You want bools, not bits. We don't need to spend more time on that. If you have binary data, you should first, before writing large amounts of binary data to your database, have a serious think about whether or not the database is the right place for this. Your database resources are relatively limited compared to, say, S3, which has lots of bandwidth. And probably costs you less per hour of compute. File systems, pretty good solution for storing files. That said, sometimes you do have binary data that makes sense to keep in the database. A good example is PG cryptoed data. There are other cases too. It can be occasionally helpful to get the MD5 sum of that data and store it somewhere. Make sure you're getting what you think you have. And mostly you will just put that in and leave it alone. The byte A type is how you store that. So data types to avoid, because I see these in the field sometimes, don't use money. The money type is a legacy of Postgres' very early period. It's not good. It's not well implemented. It doesn't catch fire all the time and destroy things, but it's very, very janky. And if you go and read the C code, it's like just use numeric instead. We already talked about timestamp and time and serial versus big serial. Some of these things are things that you usually don't want. Sometimes people will come to me and say, oh, I'm using float or integer. You should probably just use numeric, right? There are people shaking their head in the audience. This is coming back to my original theme. If you are doing a scientific computing application and you understand that there's overhead or you're packing gigs of float data and you don't want to change precision and all these kinds of things, there are certainly times when those data types are appropriate, but it's sort of one of those, are you sure that what you really need is a float right now? Because are you really going to be thinking about how precision of floats change when you're pulling data out or doing operations on it later? Are you thinking about what index types are going to be supported by those data types down the road? Consider just using a numeric adding constraints. Again, there are times when, for performance reasons, this may be important, but prove that to yourself before you go down that road. Don't just use it because you think it might be better. We already talked about varchar and char, bitstring. I would encourage you not to use the XML type. not just out of personal prejudice against XML. Obviously, there are times when you may have to use it. But the XML type in Postgres is built on top of a not terribly good piece of code called libxml2. Over the years, there have been a lot of security vulnerabilities in libxml2 that we've seen at Heroku. It's your only real option if you want to do XML-based operations in Postgres. But for most people, for most use cases, I would encourage you, if you have sort of semi-structured data, to either use an HStore or best a JSONb. Last, you probably don't want to use the JSON type. And this is the one that I screw up all the time, which is you go and you're making a table and you put the JSON column in. You probably want JSONb. The difference between JSON and JSONb we're going to come back to, but just remember the B is for better and make that your default. All right, how do data types work? How many people know how data types work internally? Couple. Okay, good. This will hopefully be interesting to you. A data type is a row in the PG type table. If you have Postgres on your laptop, you can say select star from PG type and see what types you have and what they do. So the components of that row are a user-friendly name to remember, like bitstring or XML or JSONb, a type name in and out function, and a send and receive function, which performs a similar function for binary representation. Sorry, I should unpack that. The type name in takes a textual representation of that type and converts that into the format that will be stored in the page. And out does the inverse. It takes the page storage format for that value and converts it into text to send over the wire. The send and receive do the same thing, but for the binary wire protocol. So send and receive, if you're in binary wire protocol mode, they do that. There will be some functions associated with the type usually, a nest, average, hostname, etc. And operators. An operator is any number of non-ASCII characters in a row. Please don't abuse this. So the basic flow is that a value comes in as text. It gets sent to that function. The function will call palloc, Postgres alloc, to get some memory, either a fixed size or a var len a, which is a variable length value with a header that represents the length of that data. Then that will be stored as an attribute on a tuple. The tuple is packed into the page. The page is written to disk. And when you have C language functions that operate on that, so if you've defined, say, host name or JSON sort of parsing, they'll usually work on that in-memory representation of it, not the text representation. This is, for example, why PostGIS, the geospatial library, is really fast, because it uses really efficient storage mechanisms that can basically be memory mapped out of the page and then into the geospatial libraries that system depends on without any translation or parsing in between. This looks kind of like this for those who want to get into it. This is a Postgres page. Items pack in from the front, tuples come in from the back, and whenever you overflow your 8K, you start a new page. If you have large data, it might get pushed out into a toast table. People know about toast, the best thing since sliced bread? That's also a bad joke from the manual. If you're ever feeling bored and want to read a 3,000-page manual, I cannot recommend the Postgres manual highly enough. It's a wonderful read. Toast is a system whereby large values, which might exceed that 8K, are pulled out of line, compressed if there are savings, and then stored separately with a pointer left as the value back. Now you might ask yourself, like, is that really efficient? You probably don't want large values in your rows, because usually if you're querying a database, you're not querying on the contents of those values. Those are sort of the payload that comes back. So if you were storing like a HTML record, you would usually query on the metadata and then return the record with its toast values. So what happens is, transparently and behind the scenes, whenever you select that row, the toast value gets joined back into the tuple on the way out of the system. This is great for a lot of reasons. It keeps your rows small, which means you spend less on I/O for searching. You don't have to scan through so many pages to find the interesting metadata when you're looking through a table for a full table scan. It's also great because when you're pulling things back, right? They're stored compressed on disk. You can fit more data in your database for the same amount of storage. I was trying to concoct like a degenerate use case where if you were searching the contents of the values for everything, that it might actually be worse. But the more I thought about it, the more I realized that you're probably still better off with Toast than without Toast, because the most expensive thing in database table scans is the I/O, and Toast is storing all that stuff compressed anyway. So I believe that it would be possible to construct a query, a real-world query where Toast was a disadvantage to you, but I have not been able to construct one, and I haven't met anyone who's proposed one. In the unlikely event that you find one, you can actually configure Toast off and change settings there. Again, don't do this until you find a bottleneck, but try not to scan those big tables that way in the first place. Use a TS vector to pull out the data you need. Sir?
So which one will decide how much the length of the sheet should be in the database and the extra things go into the mining?
Which one will decide when to use Toast versus storing it inline? I think is 8K the threshold, whether or not it can actually, I think slightly under 8K determines, pardon? 2K? So at 2K, it will take the value and store it in a Toast table by default.
I think it's a little more complicated than that. The Toast blocks are 2K, which seems weird to me, but
It's, okay.
Pages are 8K.
Yes.
I think the threshold is a third of a page, but so if you can't get 3 rows on a page, it's going to start kind of look at toasting things.
The useful summary of that would be around 2K ish. Yeah, you can actually, if you go and look at and I can't get too deep into this, we have a lot of ground to cover, but if you go take a look at the PG Toast catalog tables, you can actually track all this down and see the system working. One of my personal favorite things about Postgres is just how much you can sort of pull apart the system under operation. You can actually, there are functions you can call on tuples to sort of find out what the Toast IDs are and sort of pull all that back and correlate all that yourself. Yeah.
I think if you look, if you search for a phrase, like some regex.
Phrase search regex, yes.
Regex against like TS vector or just text, not TS vector, it's very slow when the text is getting larger.
Phrase search is better in, did that land for 9.6?
Yes.
Okay, so phrase, one of the wonderful things about Postgres is that whatever thing you think sucks the most is probably either landing in the next version or landed this version. But saving yourself from scanning those very large values obviously is a benefit. You can create text search vectors and store those instead of scanning the full text if you're looking for tokens and stop words. And full text search in Postgres is incredibly robust and complicated, but you can provide your own custom dictionaries and everything else. And if you create GIN indexes over those TS vectors, then you can do lots of really efficient lookups. And you can also put them on JSonb, which we'll come back to pull out subdocuments as well. Okay. Hopefully everybody found at least one thing that was new to them in there. But that's sort of a collection of things that in my years with Heroku supporting customers, I got really tired of telling people, or just really sad every time I'd see someone making the same mistake. So hopefully you're all too wise for that. Now let's talk about some advanced types. We're going to look at a few sort of greatest hits among the advanced types. These are all types that I use and I would recommend. There are sort of some, let's just call obscura in the Postgres type collection, which are interesting, like L-tree, that we're not going to get into. But these ones are all like serious, operationally useful types that I would encourage you to go after. So let's start with arrays. What's an array? It's an array in a value. It's not rocket science. It's just an array. Now, some people have in the past sort of pushed back and said, well, but you can store this as like row ID and then an ordinal with what the position in the array is. Storing an array as an array in a value in a column is very efficient for a number of reasons. One, updating them is much cheaper than trying to rewrite a whole bunch of tuples if you want to insert or move things around. 2, they're stored, unless they get over about 2K, in line with the row, which means you don't have to go hunt them down. And 3, they're also just much easier to reason about than sort of join tables. They're easy to reference. You can use array indices. Of course, SQL indexes arrays from 1, not 0. But they're good if you have array data. I use them a lot for different things like tags. So if I have a bunch of tags on a row, I'll just create an array of strings, then throw a gin index on it, and then you can just very quickly retrieve rows that have those tags. It's a nice, handy little trick. I also use arrays interactively quite a bit when I'm doing analytics. So if I have a bunch of rows and I'm creating some window expressions or group expressions, and I'm not sure I'm getting exactly what I think I'm getting, I'll shove all that into an array value with arrayAg and see what's in there. So let's look at some examples. Building arrays, you can use the array syntax. You can parse from a string. All the values in an array have to have the same type. You can concatenate arrays together. You can add a value to an array with concatenation. Or here's arrayAg. So here I'm selecting all the distinct users from some event that I was at into an array. When you're accessing into them, you use just traditional array notation. And the containment operator is how I look things up. So this is an example of that tags I was talking about. And here we're selecting where there's this subarray. So you can actually do containment to find subarrays within an array. So you could select multiple tags at once. Question? How does a gin index work? Oh, yeah, I'm afraid that's a bit too much to get into. Essentially, you have an inverted index, so you have a wide index at the top with all of the values, and then you sort of overlay those as you go down to get just the ones that you want. So you have a bunch of basically, I'm not sure this is even a great explanation. It operates, yeah, gin indexes get big fast is sort of a trade-off there for sure. Yeah, so it is at the element level. I think unfortunately, this is a big topic to get into. Everyone's talking about JSON. Oleg Bartunov from Postgres Professional described it as saying, we made a database inside a type. I suspect this will take years to play out. I use JSON for short-lived or attribute storage. So I will often just have like an attributes column on a row, and then I'll put things in there that are not going to be around long enough to warrant adding a dedicated column for them, or where I have kind of semi-structured or more free-form data. Of course, if you keep those columns, I recommend you promote them to real columns and not just leave them as a JSON type, or people will make fun of you when your new DBA comes on the team. JSON is, of course, useful if you have true hierarchical data. If you went to the SQL Guru talk or some of the other talks here, people will talk about using recursive CTEs to join together hierarchical data. This is very slow. Postgres is not very good at this. And a lot of the time, if you have hierarchical data, you usually want sort of like these sub-assemblies all together. Also, frequently, the JSON data type is an excellent choice if you have JSON data. This is sort of obvious, but you can go to all this work pulling apart the JSON and then storing it in components in your database and then querying it back out and reassembling it, or you can store it as JSON. Now, JSONb is a binary representation of the JSON, which is more compact usually and allows for better indexing. It's based on the old HStore type. JSON stores the data as text. It's unfortunate that we have two similarly named types that solve almost the same problem and that the JSONb is almost certainly what you want. The one disadvantage, JSONb can be more expensive at write time because it has to do more work to parse it. and at query time, if you're deparsing it, it can be more expensive. In general, I think the trade-offs are such that JSONB is my generic advice. What you lose with a JSONB is the white space. Because we don't store the original JSON, we store the binary form. When you query it back out of the database, what you get out is a newly constructed JSON, which will have whatever white space the formatter wants.
I guess if you're not going to process it as or break it apart or create an index part of it, probably JSON is fine.
Yeah, well, if you're not going to do anything with the data type, JSON is fine. But what I would say is that if you're truly treating it as completely opaque, just store it in a text field, because then you're not paying any overhead at all. But again, coming back to the kind of like, what should your default be? I would encourage you to use a JSONB, because that's more future-proof in terms of if down the road you want to do more elaborate things, you sort of keep the door more easily open to that.
And I think it supports wider range of tasks.
Yes, JSONB supports more index types and more query types and more operators with better performance characteristics if you're going to be working on the values. Don't just make a table that's ID and then JSON. Really don't do it when you have basically a table in the JSON, and I've seen this, just don't, it's not great. Okay, so making JSON's really simple. You just give a JSON, you cast it to JSONB. Adding new things, you can append documents together for updates. To access, you can use the arrow and then what's known colloquially as the stabby arrow. So an arrow will give you back the JSON value. So if you have a string, it'll give you back a quoted JSON type string. The stabby arrow will return the internal value. So if I selected with a stabby arrow, I get back Ottawa. If I select with a regular arrow, I get back the value. I think, sorry, I should have one arrow there, but the documentation is correct. You can also extract, there are lots of operators. I will caution you as you're using these, it's very easy to accidentally use the JSON instead of the JSONB form of the operators. This is an unfortunate thing that I tried to fix, but wasn't bright enough. But if you don't use the JSONB form, Postgres will cast the type to JSON, perform the operation, and then cast it back to whatever you need to store it again, or keep it as JSON, kind of depends. But just be a little bit careful about which form you're using and make sure that you're being consistent. And if you're storing as JSON, don't use the JSONB ones for the obvious inverse reason. You can decompose JSON into records. So here we're taking JSON to record set. I guess that should be JSONB. And we're decomposing, I guess here it doesn't matter because it's just a string. And we're decomposing that into sort of a virtual table. Postgres is or SQL is a strongly typed language, so you need to actually provide column definitions, or it won't work. And when you're searching, you can search by key or subdocuments using the question mark or containment operators. Okay, everyone good with that? Any questions about JSON at a high level? The manual is very comprehensive. Spend some time in there. Take a look. There's lots of really good, useful things. And I'll also just say PLv8 works really well with databases that have the JSON type. So enums are enums, as in any language. I know it's sort of silly to say this kind of thing. You can create enumerations. They're useful in the sense that they basically constrain you to a limited set of labels and then are stored under the hood as numbers, but sort of appear as the label values that you put in. So like in other languages, you can create an enum. You can treat them as a text value and match on it. You can insert text values. And if you try to insert something that's not in the enum, Postgres will complain to you, and you can modify the enum by inserting new values into it. You can perform less than and greater than on enums, but on behalf of your fellow code maintainers, please don't do that. I guarantee you somebody down the road will curse your name. I want to talk about ranges. These are one of my favorite types. Are people familiar with ranges? Who's using them? No one. Okay, a couple of the Heroku people. So, ranges are incredible. How many people have like billing data or billing relevant data in their database? Most of you, I expect, right? Things happen in time. Records are created and destroyed. Customers start and then leave. A range type has an upper and lower bound and then a bunch of operators that basically let you query on this. So, and you can, depending on how sophisticated you need to be, you can have inclusive or exclusive bounds. I believe square is exclusive and round is inclusive. Or, yes? Nothing lasts forever. Your customers don't last forever. They're fast, and they have exclusion constraints, which are really cool. There are a bunch baked into Postgres. You can define your own. It's in the manual. And you can also create them mid-query. I do this a lot because you may not want to migrate your database to start taking advantage of something like this, but you may have a created at and deleted at column already in a table. And so you can just create a range with a constructor, and then you can start querying on it. Anything that's null is treated as positive or negative infinity, so if your user hasn't been deleted yet, then the deletion time is considered forever from now. And then you can start to do inclusion queries. So here we're finding all of the users whose created at and deleted at intersects with Christmas Day, right? So they were around on Christmas. So, right, like you can start to perform these really powerful things that are very annoying to think through and have all these weird corner cases using very simple, robust operators. That's awesome. Even better, you can create a functional index on that. And then now this is really, really fast. So this is really cool. This will save you a lot of table scans. And I use them all the time with Windows functions. So you can make a bunch of ranges. Say here I am binning a bunch of ranges into 4-hour chunks and then basically joining the first to the next to create the ranges. So I can say, if I have a bunch of events about a topic, I can say, well, the next event on that topic came in at this time, so this was happening until then. This is good if you have sort of time series data and you want to perform analysis on it. Talking about window functions is, again, a bit much scope for here, but these things all pair together really well. So it's fast, it's convenient, super useful. And exclusion constraints, a Jeff Dean joint, he's a local developer who added exclusion constraints. They let you say, okay, I don't want you to create records that violate this constraint. So here what we're saying is, if I have a reservation, I don't want you to create any two reservations that have overlaps for the same room. If the room is equal and the overlap operator says true, don't allow that record to be inserted. So there's all kinds of really interesting data consistency guards you can add with exclusion constraints. Questions about ranges? They exist. I use them most with times for obvious reasons, but you can use them with numerics, you can use them with lots of other types, and you can add your own if for some reason you're doing inet blocks or something. Okay, let's talk extensions. That's kind of my highlights of the core. This is stuff that's baked in, that's in, either in Contrib through create extension. These are all things that I use or have used for real production work and that I would recommend to you. I realize it's sort of a wall of stuff. I hope that you'll come away with this kind of thinking like, oh, next time you have a problem where these might come in handy, you'll kind of think, oh yeah, there was a thing about that, and then you'll go look in the manual or look at my slides or whatever else and go a little deeper. I want to move now to talking about things from the community. So we're going to talk about extension types. This was actually the extension that inspired me to write this talk. We were talking about this problem earlier, which is you have all these email addresses. Emails are like one of these great examples of things that are on the surface simple, but to get all the details right are very complicated. And then there's all these sort of surprising performance sort of complications. So we can do this thing we know already where we add reverse functional indexes. But that kind of sucks. Why don't we just have a type for email addresses and then we can call intelligible, meaningful names for the functions. And if we discover that there's some problem, we can fix this once upstream and then all share in the benefit of that implementation. So Peter Eisentraut wrote this a while back, where now you can install this extension on a database, and now you have an email type, and by default, they're actually stored in domain username order, which means that the indexes you create will naturally cluster usefully around domain name rather than username, because who cares what usernames your users have? You care what their domain names are usually. Similarly, URLs are another thing that, does anyone not have URLs stored in a database they use? All right, we all have URLs in our database. They're a pretty well-determined spec. They're a complicated spec again. There's a lot of colloquialisms. But if you use the URI type, you can select the path out of a URI. You can create an index on the host name. You can add constraints that say, I only want to store HTTP or HTTPS URLs in this table. So these are really cool and really useful. If you have the extension, but you already have data, again, I alluded to this earlier, you don't need to migrate your data to start taking advantage of this, right? You can just cast it to a URI and start calling those functions. Talk about a few more special purpose types. Postgres has all these built-in geometry types. I wouldn't really use them. There are lots, but I think that the usefulness of them is almost entirely superseded by PostGIS. Is anyone familiar with PostGIS? Okay, so PostGIS is basically geospatial information. The built-in things kind of give you box-box intersection and distances between points and lines and some nice operators and functions for that. PostGIS is like the big granddaddy. There's like thousands and thousands of functions, map projections and raster data and different geoids. And I used to work in oceanography and spend a lot of time worrying about these kinds of things. PostGIS is actually what got me into Postgres way back in the day. It's got whatever you need, it's in there. And it takes advantage of sort of having one geometry data type. It's got really good performance characteristics because it's used by professionals in the field all the time. It's not built in. You'll have to install it as an extension, unlike the geometry things. So if you have like really lightweight use, you might find the geometry stuff useful. But if you have maps or mappy things going on, you should use it. Here's an example of what it looks like. So here we're sort of getting the length in kilometers of a road with a certain name within a certain geometry. For network addresses, there's some built-in types, but again, they've been largely superseded, I think, for people doing serious work here by IP4R, by Rhodium Toad on IRC. If you have a lot of network addresses in your life, if you're in security or registrars or things like that, you should definitely be using IP4R, almost definitely. And new and exciting to me, just discovered this recently, physical units type. This is fantastic. We lost a Mars rover because people did unit conversions wrong, right? That's hundreds of millions of dollars that Postgres could have saved with this free software. But basically what's happening here is we're adding units to values, and then under the hood, the system knows dimensional analysis. Can these types be added at all? Is that an error? If you add meters, you get kilometers. Here we're dividing newtons by kilograms and getting meters per second squared. Right, so this is really cool and exciting. And this is landed pretty recently, but I've been playing with it. The code looks pretty good. It doesn't support imperial units yet, sorry to anyone who feels really passionately about miles. But this is early days in terms of support for like the sort of outer reaches of the SI spec. Like it doesn't know about different versions of Celsius, but definitely encourage you if you have physical data to start looking at this. There are, for people who are really into these sort of things, PostBIS, if you're a bioinformatics person. There's a whole module, a bit like PostGIS, but focused around DNA querying. And there's a pretty good but very stale PG currency, which tries to solve a lot of the problems with the money type and has support for different currency flags and so on. It's not perfect, but worth taking a look at if that's your jam. These are more performance-oriented. Fixed decimals are occasionally important for some applications. That means that you always have the same amount of precision below the mantissa. Hyperlog log's not really a data type, it's a data structure. It's sort of an approximate index. There's a type for that. And that's kind of my survey there. So we're short on time, and I know from having given this talk before that everybody's brain is starting to hurt a little bit. So I'm going to move quickly through the DIY part. You can make your own data types. I mean, coming back to that Postgres paper, that was a big part of why Postgres exists. You can do it at runtime in the database. And sort of the most basic one is you can create a domain, and you could roll your own email type, for example, or take that existing URI and say, I only want HTTP URLs. When should you use domains? If you have a really stable specification, don't do names like you'll get it wrong, first name, last name. Like there's lots of parts of the world where that's the wrong model. It's a great paper from the W3 about how to get this right. Don't do postal addresses. They're different around the world, but like maybe you could do postal code. Remember the +4. But you can use domains to basically apply data constraints at the value level. Here's a really trivial example where I'm poorly implementing an email by just saying any number of characters followed by an @ followed by any number of characters. And here I'm doing something similar where I'm adding a check that says, oh, the scheme should be HTTP. Domains aren't compatible with arrays for boring implementation reasons from long ago. Composite types kind of go back to the original foundation of Postgres. Whenever you make a table, a corresponding row type is created. These are, I haven't actually generally seen this be super useful, but you can actually, if you're, I use this sometimes, which is I actually select the row from the table. I use this in window functions sometimes and joins to just bring along the whole row as sort of a unit in a single value. You can create your own complex types. So here we're doing, there's point as a built-in type. Here's a point 3D with an X, Y, and Z. Generally, again, limited utility, but it is available if you want it. You can dot into values to get to their members. So here we're saying, users.email. And you can always define your own functions over any of these types with create function. You can build them in any language you want. PLPG-SQL is really slow because it's always interpreted and there's a lot of context. PLV8 is pretty fast. PL-SQL cheats and does query rewriting, so it's very fast. But benchmark, it's surprising how much of a difference it makes. You can do your own aggregates, define your own aggregate functions. You can define your own operators. Don't do what I'm doing here, which is be cute and use like 3 or 4 ASCII art characters to try and express your operator concept. I'll just leave it at that. So in closing, I want to just talk a little bit about the types I think that are still missing. Currency type, there's like a stale old open source one and a really bad built-in one. I think there's an opportunity here. Money is complicated and hard and subtle. And as with time and geometry and all these other types, I think as a community, we would do really well to rally around this problem and solve it once together correctly. That hasn't happened yet. But you can imagine being able to have sort of running tallies of different currencies in the same type that are flagged by what currency they are, and to be able to convert them or add them and subtract them and get meaningful results like we can with intervals. Images are another thing that wind up in databases a lot. There's good reasons and bad reasons for that. But since we're putting images in the database anyway, and we're creating images with things like PostGIS, it might be nice to actually have an image type that lets us perform basic operations and query them for size and shape and so on. I have a background doing feature extraction in music. I did everything on the file system. It would have been nice to have a database that supported. Again, this is one of those domains where there's a lot of complexity in the data. And if we can build the thing that we can share as a community, then fewer people will make sophomoric mistakes when they go and implement sort of the naive versions of these things. So if you're feeling motivated, those are some types I think could be fun to have. Congratulations, you've all survived to the end. I will very succinctly recap how we got here. So even this slide is too many things to remember, I'm sorry. But for your basic data types, use text. Stick with timestamp, TZ. That supports time zones. And use big serial or UUID instead of serial or integer. Pardon? And numeric, yeah. For advanced types, JSONb is got all the hype, but don't underestimate the humble array and spend some time with range types. They're incredibly useful. If you're going to roll your own, you can use domains to constrain existing types. You can build composite types or use the ones that are already present in the form of your tables. And you can always add your own functions, operators, and aggregates. There's no reason why you shouldn't. Well, except good taste in operator design. And there's a ton of stuff out there in the community that you can draw on, and it's growing all the time. And every time I've given this talk or talked to people, another data type pops up or I discover another thing. This is, I think, a really interesting space that there is less there's a lot going on, but not a lot of people know about it. And people have built all kinds of cool types that aren't open source. Like I met a group that had implemented fully like a medical spec that let them query injuries. So like there's a standard in the medical community for ailments and injuries, so you can sort of specify like, oh, it affects the left half of the body below the knee, and they could write these queries that let them extract all this from a standard data type and perform operators on it. I think that's really cool. So consider writing your own, consider open sourcing them, and consider sharing them with the community. There's lots at PGXN, the Postgres Extension Network. Sir?
Are there any standards like between the databases? Like we encountered some issue when we were migrating the data from Oracle to EDB.
Yep.
And we have issue with the open cursor data type that doesn't support when we are migrating. And finally, we couldn't able to transfer the data when it doesn't agree to upgrade also, like PG upgrade failed with that. So between the databases like Oracle to Postgres, then are there any standards that
No.
they have support?
The short answer is no. The short answer is that the SQL standard is a beautiful lie. Every database provides a grossly incompatible set of functionality, and more significantly, a wildly divergent set of sort of performance and operational characteristics that make attempting to migrate a robust production application between data platforms an incredibly time-consuming, painful, and expensive task. If I gather you've been through this, I have never seen it be different. Whether you're coming from MySQL or Mongo or Postgres, it's going to be a hard project to move databases. Even if they're very similar on paper, the reality is, the way query execution breaks down in the corner cases is going to be the difference between up and down for your application. And you can't take that for granted, and you have to know there's going to be a lot of engineering going in. So I find and this is my personal bias, I would rather have a database that did what I need than a database that followed a standard built oppositionally by competing corporations 30 years ago who are all trying to one-up each other, building specs that have never been implemented and can be proven to be impossible to implement. I would rather have a database that works for me and my application and my needs today. Sort of the flip side is also, look, it's an open source community, it's an open source project. Pull requests are always welcome, and improvements are always invited. And I realize that's kind of the go F yourself from an open source community version of an answer. But in all sincerity, finding ways to participate and give back and surface those problems and ask those questions and either contribute solutions or just well-documented examples of the problems that will help, even if not you, the next people through.
Before start migrating the data itself, if we have some check, like these data types are not get supported.
Yeah, it's
Such kind of tools, then we need not only take two data sets from different, like ours is a product-based company, so we can take different backups from different people, and we can test it and make sure,
sounds really cool. Greg has a.
This is a product that AWS Data Migration Service aims to do by having a schema conversion tool that specifically calls out these problems. It's a business. It's not open source, so your mileage may vary, but there's definitely an opportunity there if anyone else wants to create an open source version.
Yeah, and there have been various projects over the years. ORMs try to provide intercompatibility, and there's database migration tools. But the reality is that all of this is a moving target, and everybody's database is different. So your mileage may vary.
There's one other mistake you can make in this area,
Yeah.
which is to cripple your application. We won't use these features
Yes.
in our database because we might move databases.
Yeah, if you've got them, smoke them. That's what I say. If you were on Mongo, you'd use all the Mongo things, right? If you were on Redis, you're going to use Redis. If you're on Cassandra, you're going to take advantage of Cassandra. And even if you try to stick to SQL Standard, my opinion from having seen lots of people in the field talk about this is that you're really just crippling yourself, right? Postgres' strength, the thing that Postgres is so much better at than anybody else, I mean, there's a few areas that it's much stronger, but this data types and extensibility and the ability to create your own and take advantage of what's out there, that's huge. Other people don't have that, and if you're using Postgres, by golly, you should take advantage of it. So thanks. I'll take one more question maybe. Time zone? Oh, so the server has a time zone, and it's probably going to change someday for stupid reasons, or it's going to be set wrong, or an application server is going to be set wrong, or you're going to launch an office in a new place and their servers will be set wrong. And if you're storing things with time zones now, you're more likely to survive that. Maybe your app's not compatible with that and prefers to manage all that very particularly. My experience has been more that people make the other mistake, and they're like, oh, well, I don't want to spend the extra byte for a time zone. That byte is there anyway, you're just not using it. So you're not saving any space or making your app more efficient. But obviously, if your app prefers to control the time zone, I wouldn't tell you otherwise. My argument is that remember that your default should be to add the time zone. I've seen so many people with so many regrets for not doing that over the years. So hence the advice. Closing comment from Greg? Okay, sure.
Extremely quick question. Why can you not do a GIN index on a UUID array by default?
Patch is welcome? I don't know. You know this. You know as much about this as I do. Yeah. I mean, no one implemented it would be the short answer, right? It needs some operators. Yeah. And there's a short list of functions you need to implement, and probably you can implement whatever that, it's probably an aggregate function is missing, and if you actually look at the error message, it may point you the right way. Okay, thank you, everybody.